She has a academician and researchers. She contribute the more than 25 journals in SCI and Scopus journal publications. She got the 10 patents. She 10 patents. We are extremely fruitful to have such a distinguished personality, Amnist, as uh, today grace this occasion and share her valuable insights. On behalf of the Department of Civil Engineering and PSU College of Engineering and Technology, I extremely warm and respectful welcome to our honorable chief guest, Dr. Muthulakshmi ma'am. May I now request her to kindly accept our invitation and enlighten us with her valuable words. Thank you.
Okay, and good evening, dear colleagues and HOD Civil, and then Dr. Lokesh. Thank you for your nice introduction about myself.
Thank
And
you, ma'am.
okay, I would like to share my screen first. I hope you could able to see my slides,
Yeah,
right?
ma'am. Visible, ma'am. Yeah,
Yeah,
ma'am.
okay, it's visible. Okay. I just want to. I don't know how to.
Go to your slide, ma'am.
Yeah, yeah. Okay. First, I would like to sincerely gratitude the Department of Civil for inviting me to deliver this talk and arranging this excellent platform for gaining knowledge about this thermal infrared camera, that is a smart thermal vision. And then it is my pleasure to be a part of this program. Today I will be speaking about smart thermovision for unlocking the invisible thermal signatures in cross-disciplinaries, that means mainly in engineering, science, and then healthcare. And then this today's session will not focusing on capturing the thermal images, but on capturing thermal images, not only in that, but we are going to understanding the correct interpretation and avoiding the common pitfalls. That means common manual error will be there. So how could we able to rectify those pitfalls, and then real world interdisciplinary applications. Yeah, so in this session we are going to focus four different major objectives. The first one is we should know about the how infrared thermography is reveals the thermal gradients in the particular target, particular objects, particular subject, whatever. We are going to see the invisible thermal gradients behind this using this camera. The next one is correct interpretation, how we can avoid the common mistakes while doing the thermal analysis. And then third one is the key applications in engineering, science, and healthcare disciplinaries. And then finally, we end up with how we can develop our skill in taking, that means collection of, sorry? Okay. Presence. Sir, is this okay, sir?
Now we hear you.
Okay, fine. I just took one screenshot. Okay, fine. I'm moving into that. And then these are all the major objectives. And then finally, we end up with how we can develop data collection, thermography collections, and then analysis, how we can write the report for quality assurance. See, finally, see whatever in it may be a civil engineering, electrical, or material science, or science, healthcare, medical field, and then environmental engineering, whatever we are going to, finally we are going to present our analysis through quality assurance. So for that we have to prepare the reports. So finally we will I will share some slides for how to prepare the reporting based on the thermal infrared thermography results. And then this is the major outcomes. These are all the major outcome of this session. The first, we will understand the real world application of infrared thermography, followed by actual field practical experience. And then this is act as you will gain a non-invasive, that means non-contact monitoring tool. We are going to learn about that, how the tool is working, and then why we are using this one, and then how we have to apply in the real world application. And then finally interpretation. Finally we end up with this industrial readiness. These are the major learning outcome of this session. And then first we will go into the objective one, that is seeing the invisible. So how the infrared thermography reveals the hidden thermal phenomenon. That means we are going to see the invisible. See, normally we have this. Normally, the human eye, naked eye, we can't able to see the temperature differences behind the object. So when we are applying this thermal infrared camera, we could able to identify the slight modifications, slight changes in temperature. We could able to read through our naked eye. So this is, before enter into this objective one, we should know what is it, and then how it works, and then why it is. See, whenever we are going to start one new project or new work or new things, means we should ask ourselves why I have to choose this one. And then okay, already I chosen this one. Okay, what it is, and then why it is, and then how it is going to be work for in this case. So with these three important questions we have to ask, this will give answer to what is the major application behind the thermal infrared camera. So first we'll start with what is infrared thermal camera. See, this is thermal infrared camera has an emerged as a powerful non-contact tool and act as a non-destructive sensing technology capable of visualizing thermal signals across a wide spectrum of scientific and industrial engineering domains. See, with recent advantages in the smart sensor, high resolution thermal cameras. So this is act as a, this also mainly act as a quantitative inspection tool, not only invasive, not only non-contact. In addition to that, it acts as a qualitative inspection tool. When we are seeing the thermal imaging device that detects the infrared radiation emitted by the object, and it converts into the different visible colors. So that is also called as a infrared thermography. This thermal radiations plays a major role in different disciplines, mainly in mainly in engineering, and then science, medical field, and then healthcare science. And then this is the major what is infrared thermal camera, and then this is also so known as infrared thermography. See, for this camera, we have a specific softwares which is available in our market. When you are purchasing your camera, that itself you will get some softwares. Using that, we can able to analyze the particular thermograms, that means particular thermal images. From there, how we can extract, how we can collect the data from single image, and then we will reporting based on that interpretation. Finally, we will conclude with the quality assurance. We will make that. So the imaging device normally detects the infrared radiations emitted by the object, and it converts it to a visible color images, that also called as thermograms. Okay, the thermograms, how we could we are getting thermograms means they translate the different temperature into different colors. So based on the color only we could able to tell. Then say, when we are doing your interpretation, we should concentrate our not only in color, we have to numerically we have to see the temperature difference between the object and then the normal images. So this is the major criteria behind this infrared thermal camera. And then this also used for, see, for what purpose we are using this one is, we this allows us to quickly identify the hot spot and cold spot. And then based on this hot spot and cold spot, we could able to give more concentration in that particular area. And then is there any fault, is there any disease occurring, and then is there any inflammation, or is there any environmental polluted area. So based on that hot spot and cold spot, we can able to give our interpretation. And then this tool is placed as a safe for us to handle, and then instant, it will give the instant temperature reading without touching the object or subject. So that's why it is called as non-contact, non-invasive tool. Okay, this is about infrared camera. And then this is infrared camera. We should know about the infrared radiation. What is infrared radiations? Means any object that has a temperature above absolute that emits radiation, that is called as a infrared radiation. So here we are seeing the infrared. We have a five different categories: near infrared, NIR, that near infrared, and short wave, and then mid wave, and then long wave, and then far wave. Today we are going to talk about the long wave. That means the spectrum ranges between 8 micrometer to 15 micrometer. So we are going to look about this long wave infrared camera. So this is the entire spectrum of electromagnetic, and then followed by working principle. Okay, how this infrared camera is working. See, basically, according to the black body radiations, this thermography is working, allows us to give the thermal images. Mainly three laws behind this radiations. Planck laws, which describes the spectral distributions. This is going to be describe the spectral distribution. The next one is Stephen Boltzmann's law, that is related to total energy of temperature. So that is related to total energy of temperature. The final one is Wind's displacement law, that mainly links with the peak emission wavelength to the temperature. Based on this three particular laws only, this thermal infrared camera is working. So all the objectives emits certain amount of black body radiation. So this sensor, this going to detect the particular radiation. Based on that radiation, it converts into the electrical signal, and then finally we will get that after processing, amplification, and then finally we will get our thermal images, thermograms. So this is the basic principle of behind this thermal infrared camera. And then one more thing, it is so in this image you could see the difference between the visible photography and infrared thermal photography. See, visible photograph, we need some light sources, but the thermal works has also been able to capture the images, capture the objects, what is the condition, what is that existing situation is behind in that particular object. So we can able to see in the darkness also. See, the history of the thermal camera is it's started in the 18th century. They discovered the infrared radiation. See, initially we started using in military applications for finding the enemies or finding the any objects around our borders, and then followed by aerospace, and then so in this is two area only initially we started, but recently we are jumping into the different field in science, medical, biomedical, and then see, currently we are using the dentistry, and then physio, and then veterinary science, animal models. So we are this thermal infrared camera is playing a major role in different disciplines. So this is the history and then working principle of thermal infrared camera. And then we should know this thermography have two different types: passive thermography and then active thermography. And then our camera, this thermal infrared camera, it belongs to passive technique, because which is giving the naturally occurring heat differences. So we are going to get the natural heat differences in that particular object, particular target. When we are coming into the active thermography, we have to support the external energy sources for getting the thermal images, for getting the data. So this is the difference between passive and then active. Simple word, I'm telling that natural heat signature emitted by object, that is called as passive thermography. Active thermography means applying a controlled heat flux to the object and measuring how the surface temperature changes over the time. So this is the difference between passive thermography and active thermography. So passive thermography, where we can be able to use means in electrical inspection, building diagnostics, and medical thermography, and process monitoring. Process monitoring is not nothing but industrial manufacturing units. So during this manufacturing process, we could able to identify, is there any fault, is there any leakages, is there any overloaded, so we can able to, without stopping the manufacturing process, we could able to tell. So in that purpose only we are using the passive technique. See, when we are coming into the active techniques, means active thermography is mainly used for composite. This is civil engineering person can use more this active thermography, because the composite inspection, subsurface detect infection. See, one thing I forgot to tell, when we are using this thermal infrared camera, is mainly taking the surface temperature only, not subsurface, not into depth of the material. We are going to the surfacely distributed temperature only, we are going to collect the temperature in that particular target. So this camera only can get the thermal temperature, the thermal gratitudes from the gradients from the particular object, means based on the surface distribution pattern of the temperature. So when we are using active thermography, means we will give some external source of energy to find out the fault or corrosions, and then any adjective, that means joints breakdown, leakage, whatever. So we are using the external source of energy to find out the defects. So in that case, where we can apply this active thermography, means composite inspection, subsurface defect detections, and bond quality testing, and then pipelines and tank evaluations. So this is the different types of passive thermography and active thermography. And then this is the deep classification of infrared thermography. This is in active side, we have a lot of options. And then when we are focusing in the passive one, means no, there is no external heat is required for to find out the fault only. And then today's session we are focusing only in passive thermography. And then in this is the visual picture versus thermograms. Anyone can able to read anything from this picture? Okay, let me explain this thermograms versus visual pictures. The first images, the car is in that on the road, so we can't able to see the temperatures. See, in that thermal images, we could able to see the line, the tire mark. That means due to the friction, there is a mark is there. So there is a temperature difference between the normal road and then this tire mark one. So this is the difference. See, from naked eye, we couldn't able to see the what is the temperature in that area, in that targets. So we can able to see the minus, that means 0.05 degrees Celsius also. We can, the accuracy of the picture, we can able to when we are using this thermal infrared camera, we can able to see this much difference also, we can able to see. See, moving into the next one, the dog is lying down on the floor. So why it is the darker color, the other part will be in blue, the purple color. So purple color will represent the cooler area, the both eyes, and then this nose part, because the dog is breathing, so the air circulation is giving the higher temperature, showing the higher temperature. So this particular area giving the higher temperature. due to the breathing process, and then the ocular surface also we can able to see the higher temperature. This is the difference between the visible picture versus thermograms. The followed by third image. So in that visible image, we can see that there is a three tumbler of water. The final one beaker also have a water, but we couldn't able to tell which one is coolest one, which one is hottest one. So when we are seeing through thermal infrared camera, we can able to tell which part of water is cooler and then which one is hotter. So in this image, the first cup have the coolest water, and then the final beaker, the small beaker, shows the highest temperature. That means the hot water is inside the beaker. So this is the difference between the normal images and thermal images. And then finally, the next one is, we should know, see, before that we have seen the what is infrared thermal camera, and then what is infrared images, and then how it is going to work. So how the camera is working. First, it is a very simple method, a simple protocol we are following. That means the camera, it detects the infrared emitter from an object. See, taking for example, take one object, for example, one apple. You just place it on a table, and then you just focusing the apple and taking up infrared and detector. Our thermal infrared camera detects the object, and then it's getting the information from the particular object that transform the amount of infrared radiation into the temperature format, and then finally it displays the infrared images. This is the basic workflow behind the thermal infrared camera. The next one is, this is a detailed one, what is taking place in infrared thermography. The object, and then it's passed through the atmosphere also, and then scanning, condensing, and then detection, amplification, and display. Finally, we are getting the thermal infrared images. So this infrared images create a images based on mainly intensity of the emitted heated by the object, based on the intensity of the emitted heat by the objects, so subjects. So this is the basic workflow behind this infrared thermal camera. See, when we are looking into the camera, okay, we have a camera facilities, okay, we know what it is and we know how it is working. But when we are handling this kind of thermal infrared camera, we should concentrate on major three parameters. The first one is performance parameters, second one is measurement accuracy parameters, and then imaging and operational parameters. So we have three different parameters. See, this is nothing but the pixel. See, when you are going to buy some new mobiles, so you obviously we will see the camera specification. Apart from that phone specification, we would concentrate in that how the camera clarity, and then it give more that means clear images, and then we used to watch those things, right? So in that case also, so in this case also, we are going to based on performance, how we can able to tell this camera is going to be give an effective results after taking the thermal images. So on what basis means resolution, based on the resolution, so number of pixels in the sensor. See, this is a different pixel size images are displayed here. The first one is 80 into 80 pixel size. Then this next one is 384 288 pixel size. The next camera picture taken from the using the 640 into 480. Say when we are increasing the pixel size, we are getting the more clear picture, and then we will get more detailed images, detailed data about the particular subject. So we have to, when you are choosing your camera, you have to concentrate in that resolution. You have, when you are going for higher resolution, you will get a clear image and then detailed images, which is helping us to better identification of small targets at a great distance. Also we can able to take, when you are choosing your camera with lower resolution, we couldn't able to cover our particular objects, and then we can't able to tell the small difference also we couldn't able to tell when we are using the lesser resolutions. So we have to, when you are choosing your camera, please have a look on, please have to choose the higher resolution camera. And then the next one is important one, thermal sensitivity. The thermal sensitivity is mainly by the NEDT, means noise equivalent temperature difference. So this is nothing but the amount of infrared radiation required to produce an output signal. See, when we are taking images, where we have seen already the work flow, that means IR radiation converted into electrical signal and then converted into the next one is amplified and then processed and then image display. So when we are getting some signal, then only we can able to enter into the amplification process and then image display. So the amount of infrared radiation which is required to produce an output signal, so in that amount is very necessary for making a good performance. So less than 30 millikelvin is giving a better performance, but in our lab we have only 50 milli kelvins, because we are currently using concrete samples and then polymer samples. Sorry, excuse me. So when you are going to for medical or electrical, and then in that case you have to prefer the less than 30 millikelvin, that you will get better performance of thermal sensitivity. See, in this image also you can able to the better performance. When we are choosing the less than 30 milli kelvins, we will get a clear images of the particular temperature pattern we will get. And then moving into the next parameter is a spatial resolution. So okay, did see the spatial resolution is nothing but a small, see it indicates the smallest object size. So when we are choosing this specification with the camera with this specification, spatial resolution means we can able to identify the small object size also we can able to detect using this spatial resolution. And the next one is a field of view. Field of view is nothing but width and height of the area being viewed through your lens. So the lens is going to be covered this particular area, means that is width and height. It describes through field of view. So these four parameters, which one? Resolution detector, and then thermal sensitivity and spatial resolution and field of view. This all four comes under in the performance parameter. The next one is measurement accuracy parameter. So based on the accuracy only, we are going to measure the parameter. So initially it's playing a major role, which is what? That is emissivity. Emissivity is nothing but the ability of an object to emit the thermal radiations. So it is scaled from 0 to 1 Deuler. So emissivity is nothing but ability to an object to emit thermal radiations. So this is very, very important. When you are choosing your camera, we should see the emissivity. Okay, we have in our Indian market, or in our market, we have a lot of thermal cameras, thermal infrared cameras. So on what basis you are going to choose? First, you have to decide what kind of objects or what kind of subject you are going to inspection, or you are going to monitoring the process manufacturing unit, or you are going to apply in medical field, that means veterinary, or it could be veterinary, or a cancer study, oculus surface temperature, whatever. So we have to decide what kind of um, application you are going to be execute. So based on that only you have to choose this emissivity. If wrong emissivity means, then your temperature also wrong. So it varies with materials. The emissivity will varies with materials, and then roughness, wavelength, and temperature. In also viewing the angle. See how you are holding the camera, the angle size, if it is 45 degree or 50 degree or 90 degree, or you are going to wall mount camera, or you are going to fix in tripod, whatever. Based on that also the emissivity will different. So we have to give more concentrate on this part, accuracy parameters. So in this tabular column, you could able to see the different materials with different emissivity. So human skin, water, fish skin, and then recently we started aquaculturing field. For that, we have to use the skin, fish skin emissivity. So glasses, painted metals, wood, bricks, cement. So these are the different materials with different emissivity. So this is the major parameter compared with other things, other specification. We have to see the emissivity, and then next one is reflected temperature. This is the another one. Oh my gosh, the reflected temperature. See, for example, here in this image, the my target is mobile, the mobile phone. So this is my target. This is red color indicates our my camera. So I'm going to capturing thermal images of this particular target. So how it is going to be reflect temperature from ambient. So the thermal energy reflected off the target surface from the surrounding objects. So that also possible. So when you are targeting your subject, your object, it's going to be influenced with surrounding objects. This must be accounted for your calculation of accurate temperature. We have to take it into account when you are calculating the accurate temperatures. Obviously, the atmospheric influence will be there, the water molecules, and then air will be there in atmosphere. That could able to interrupt your infrared radiation sensing receiving, and then surrounding objects also emits or reflect the some radiations, so that would be possible. So we must understand that the camera detects total radiation reaching the sensor or not. We should understand that. Based on what we can able to understand means, first one is radiation emitted by the target. See, our target will emit some radiation that will come to our sensor, that means that will come to our detector. And the next one is radiation reflected from the surroundings. So surrounding material also we will get some reflected will be from the surrounding materials, so surrounding objects, and then finally radiation emitted by the atmosphere. So all three we have to see when we are taking one single thermogram images. We have to concentrate in that target and then surrounding subjects and then atmosphere. And then next one is temperature ranges. See here I mentioned the few ranges, this which is useful for industrial ranges and the building maintenance ranges. So in industrial ranges, minus 20 degree to 650 degree, in extending up to 2000 degrees Celsius for higher temperature applications. When we are going for building and then maintenance ranges between minus 20 to 120 degrees Celsius, it goes up to 400 degrees Celsius. So the last one is atmospheric emissions transmissions will be there. So water vapor and then air particles can absorb the infrared radiation, so that will give wrong temperature information to we won't get exact temperature pattern of our target, so we have to do some calibration before and then after taking the images. Okay, these are all the second major parameter. Then and atmospheric transmissions. And then finally, the imaging and operational parameters. So what does this means? This is the frame rate. There's a number of images per second. See, when you're some moving object, when you're focusing the processing monitoring, in that case, we can't able to that capturing. So steady state object means we can able to tell, and then when it's a capturing a fast moving object means we have to fix the frame rate, then we have to go for taking the temperature thermograms. And the next one is spectral range. What is the spectral range? So here we are using passive thermography and then long wavelength infrared camera. So the range, the spectral range between 8 to 15 micrometer. So this is the spectral range, and then the next one is focusing point of view. So we have to fix somewhere. Otherwise, manually, if you are taking manually, means you have to. That means you should not shake your hand, and then you have to capture the images in same position for taking. See the thermal when we are according to this thermal infrared image, the thermograms, not only one images could able to give your quality assurance report. That means, so we have to take number of that means normally if you are going to target one subject means different time duration, whatever based on your scenario you are fixing the sample collection in that particular target means you should not take only one images. You have to go for at least 300-400 images for getting a high, that means getting a clear image, and then more detailed information about thermal pattern. You have to take at least 300 images of particular camera. That means in inspection related means you should not go for this. And when we are going for the classification, that means analysis part, when you are using the AI or machine learning or deep learning, in that case we have to give more input for getting a better performance. So in that case you have to take more thermography images for getting a good better results. And then Then we are talking about the color palettes. Color palettes means, here normally we have a different color palettes. See, I just want to highlight white and yellow. It's represent high hot region, and then red orange means warmer, and then green color denotes moderate, and blue and purple is a cold region. Based on this criteria, we are going to differentiate the temperature in that particular images. See, here we can the three faces on the right hand side corner in three faces. So normal resting situation, the temperature pattern is different, and then washing with the cold water, the face giving the purple and blue color pattern, and then washing with wet wipes. You are going to wipe your face. That temperature will differ. So this much differences we can able to identify when we are using this camera. Okay, and then this is a common color palettes we are following in our industries: iron pellets and black whites, or sometimes it's also called as grayscale, and then rainbow pellets. And then see, in this image you can able to see the plastic bag. Black color plastic appears in the transparent in the thermal images. So when we are using the seeing the visual images, we can't able to see his hand. When we are seeing through thermal camera, we can able to see the, because the polyethylene plastic are highly transmittive to the long wave infrared uh, wavelength. So we could able to see the hand behind black plastic bags. So here's a video of me. The previous one is visual images, and then he is hiding himself behind the under the black plastic cover. So in that we can't able to see the human behind this. And then after seeing the through this thermal camera, we can able to identify some object is behind the inside the plastic bag. Okay, and then moving to the why I am capturing. See, this is straight to point. We are going to detect abnormal heat patterns, which is we can't able to view, which is can't able to see through our naked eye. So, and then monitor the process behavior and performance in real time monitoring, and then identifying the defects as faults, and then insufficiency of the early stages, and then finally we support safe and then non-invasive diagnostic tool and decision making. These are all the major criteria for why I am choosing this camera, why I am capturing this thermal images using thermal infrared camera. Simple. Products, quality, and we are getting the quality, and then safety, and then efficacy of the particular objects. For this reason only, I'm going to use this thermal infrared camera. See here, there are some, see, whenever we are using some tools or some innovative equipments, means there will be some limitation will be there, but we can able to overcome those limitations in due courses. The researchers are deeply doing researches to overcome those limitations. Even though this passive infrared thermography is only surface temperature only we can able to correct, requires emissivity corrections. See, without doing correction, we can't able to predict, we can't able to read the exact thermal pattern of the particular object. So this is going to be complementary tool. See, not only this going to be giving the final results. In addition to that, for validation, we have to get some other secondary data or some real-time in-suit measurement and then we have to compare this thermal imaging camera thermal images, and along with the validation part will plays a major role when we are using this tool. Okay, and then this is the major flow chart, how you are going to capturing the thermal images. I just go very fast because I have more slides for you to share my experience, and then what I studied, and then everything. So just this is the major flow chart. When you are going to capturing thermal images, we have to start with first you have to identify the object, and then select appropriate thermal camera. You have to choose your own camera with good specifications, and then prepare the measurement environments. The environment should be prepared, and then set parameters. Camera parameters will be there. See, major parameters is emissivity, and then reflectant, temperature and distance, and then focus area, and then you have to measure the humidity also. These are all the major parameters you have to set in your camera, and then you will go for capturing thermal images. In advanced thermal camera, we have a continuous monitoring also. That means continuous video recording is available for continuous monitoring. So this also available for static means a single frame, we will get a single image. And dynamic, when we are going for dynamic, means this is the time series data that is going to be helpful for more accuracy of your results. And then choose the color palette. See, when you are going to compare with other things, means when you are going to compare with other images previous, and then for example, if you are collecting data for 30 days, the initial first day will be the, what is the result, second day, third day, like, means you have to avoid auto scaling. You have to fix the color palette as well as the numerical scale of temperature. You have to fix throughout the 30 days experiment. So then only we could able to compare with the 30th images with first day images. So you have to see that one, and then define the area of region of interest. You have to spot. If see, some cases in ocular surface temperature, we are going to see the whole area. And then if your electrical point of view, you are going to detect the is there any electric leak is there, so you have to point out. The spot will be helping for you. And then concrete, is there any crack or any leak, that means defect in that particular area, means you can choose the area. So region of interest is very important. The next one is analyze the thermal pattern. So the thermal pattern, see, in following slides I have few patterns. Based on that pattern only, we are going to interpret our results. So the next one is quantitative temperature analysis. So obviously we have to quantitatively, we have to tell our temperature data from our objects. And then next one is interpret the thermal abnormals. What is that normal, which one is abnormal, we have to highlight in that thermal images. So we have to see that also, and then correlate with ground truth data. And then the next one is the ground truth data is nothing but for revalidation purpose. Finally we'll come into the decision, or it may be diagnosis, or we can able to conclude of the results. So these are all the major steps, flow chart we are following for capturing the thermal images. See, these are the different cameras which is available in our market. Their applications also differ. See, there is a resolution, pixel size will be differ, and the temperature, and then focus distance. So these are the major parameters you have to consider when you are going to choose your camera. And then see, in our center in Satyabama Research Park, the Quality Assurance ND, Non-Destructive Evaluation Center, we have a camera that named FLIR
835 IR camera. This specification, see, currently we are using this camera for concrete, civil engineering work, and then mechanical work, and then electrical work, and then environmental monitoring. And then currently we are working in this aquaculture system for using this camera. We are trying to do some novel work in that. And then this is for your knowledge. I'm sharing the thermal images of surrounded by ourselves. This is the thermal images of flower, animals, and then the peoples are standing in the queue, and then classroom atmosphere of some people working, and then parking slot, and then these are all the some images. And then coming into the real world application, what are the real world application of infrared thermal camera? Means we are using in plumbing industries, and then building inspections, and then automation, and then there's AC and air conditioner industries, and then firefighting, medical industries, maritime, coastal studies, veterinary, oil and gases. These are all the real world applications of this infrared thermal camera. So in objective 1, we have seen the what is infrared camera, and then what is infrared radiations, how it is working, and then why we are taking these images, and then what are the parameters we have to consider when choosing your camera, and then followed by how we are going to take the image, the flow chart. Moving into the next one is, this is the big chapter. Just I am taking little time to this, and then just have a look on this correct interpretation, how we can avoid the common mistakes when we are doing the thermal image analysis. So the major parameters, wherever you go, when you are using this thermal infrared camera, you have to concentrate in the emissivity, surface properties, and environment. Environment is nothing but atmosphere. When you are going outdoor data collection, means in that you have to see. And then indoor also you have to see the humidity, and then atmospheric correction will be there. You have to concentrate in that. Here, see, previously I have mentioned, see, for a particular field, we have a thermal pattern, what it indicates, and then what is the major causes for that particular indicates. See, in the electrical field, panels, transformers, switch gates, and then substations. Based on this, we have some thermal pattern, and then what indicates it, and then what is, for example, one linear, what to take a localized hotspot means that what it means, loses or corroded connections. So we have to when we are preparing your quality assurance report, you have to mention we are localized some hotspot in that particular area, which indicates loses or corroded connections, and then what may be causes, due to what. You have to mention that also, increased contact resistance. So we have to mention in that also. In that way only we have to see thermal pattern, what indicates, and then what is the major causes. So followed by the next one is mechanical engineering. So mechanical engineering background, what we could able to identify the the health of motors, pumps, gearboxes, and turbines. So bearing hotspot, for example, I'm taking the uniform overheating. See, that means uniform over, if you are the thermal images giving uniform overheating in that particular pumping or motor, in that case means that indicates overloading. That means the machine is continuously running, and then is overloaded with processes, And then, so that what is the major causes means incorrect operating conditions. So the motor condition is not good, we have to advise the manufacturing unit member. So we have to stop, and then we have to look on what is the major causes behind this overloading indicates. Okay, this is the pattern. And when we are coming into the civil engineers, so civil engineer means there is some pattern, and then what we can able to indicate means those patterns, based on patterns, no, we can able to identify the moisture content and thermal bridging and delamination. Is there any air leak is there? So we can able to identify the pattern based on the indication, and then causes, what is the causes for this indication. And then this material engineering also we are applying for find out the defects, faults in the composite, and then polymers, metals. For that also we are using the thermal infrared camera. When we are coming into the biomedical and healthcare means mainly we are focusing the increased blood flow, infection area and vascular disorders and injuries. Is there any injuries there? And then we could able to find the fever symptoms, and then who is the stress assessment also we can able to identify through thermal infrared camera. In pharmaceutical industries, what we could able to identify means is mainly based on the industries. So we can able to analyze the so we can able to identify the is there any deviation, temperature pattern is different in that process condition, process monitoring. So for that purpose we are using in pharmaceutical industries. So here I have given total 9 mistakes we should avoid during our interpretation of this thermal camera. So we should not assume the brighter color gives hot objects. So the correct interpretation will be we have to see the numerical temperature value as well. So based on that color pattern plus numerical temperature value, we have to give the final result, and then check the fixed temperature scale. So we have to fix the temperature scale before you start your taking the cam sorry, taking the images. So the second one is ignoring emissivity. So you should not ignore the emissivity. So you have to, based on your materials, we have to choose our emissivity in our camera. See, in our camera we have that means normal camera. If you are taking your digital camera or your mobile camera, in that we'll go and the specification information will be there. So we can able to alter, we can able to set our parameters whatever we want. Based on that we can able to set our camera. So we have to include the emissivity. And then the third one is confusing. So you should not confuse the reflection with heat sources. Heat sources is different and reflection is different. So reflection means if a surrounding subject or object could able to reflect some radiations, your object will emit some radiations. So that is different, this is different. So you should not confusing both. And then the fourth one is auto scale for comparison. Previously I mentioned, when you are comparing, you are going to compare. Obviously, when we are taking images in time series or different days, different timing, so we have to compare based on your strategy, based on your scenario. We have to compare. So previously in day first, we got this images, day 5, day 10, day 20, like that. So in that occasions, what we have to do, you should not fix the auto scale. You have to fix the temperature range and then same color scale. So based on this only, we can able to compare your results. The next one, fifth one, is single pixel interpretation. Okay, you should not go with single pixel interpretation. So you are having one images, you are taking information, taking a thermal data from one pixel area, that is not going to be give a perform, that means perfect result for your analysis. So in that case, we have to use region of interest. That means the area and then spot and then line. We have to, in that analysis, we have to mention the mean temperature, maximum, mean, minimum, and standard deviation. So this is the correct interpretation when you are should not go with single interpretation. And then sixth one is environmental factors. So you have to you should not ignoring the environmental factors. You have to consider the stable environment and record ambient temperatures, and then you have to repeat the measurements for the consistency. So you have to take a few images of the particular uh, target. The seventh one is treating a static image for final evidence. So when you are capturing the thermal camera, that means thermal sequences or video, the heating and cooling trend will be there. You should analyze that one and then look for the dynamic abnormalities. Now, what is the dynamically? Is there any difference between the time series data? And then the eighth one is over interpreting absolute temperature. So what is the correct one is focus on relative changes only. And then the baseline comparison, you should have the baseline data, and then only you have to compare the your data. So this is the one. The next one, ninth one, is no validation, no correlation. No. You should not go with without validation, without correlation. You have to correlate with other contact sensor or process data. You have, if you have any secondary data or a real time data or what has been that in suit data, you have to compare. You have to correlate with those datas. So these are all the 9 major mistakes behind the interpretation of the camera thermal images. And then we are entering into the applications of engineering and science and healthcare. So mainly we are focusing the materials, manufacturing and maintenance. So how far the material is good quality, or is there any defect, any fault, is there any fault, is there any defect, is there or not? We are going to find out the materials. And then in manufacturing also, we can able to identify the process, the predictive maintenance. The next one is predictive maintenance also, we can detect through this camera. This all three will applicable for engineering field, and then science and healthcare. First we'll see the electrical field, electrical engineering. So in that case, what is the major applications where we are applying this thermal infrared cameras? First, initially we started with first one is electrical panel inspection, and then the next one is see the orange color. For example, I'm telling I just explained one images. See in that electrical panel inspection, due to the apart from that, the outer area, it's giving the purple and then blue color. So it is a majorly purple color that indicates the coolest area, coolest part, with the orange with that means white patches in the yellow that gives hottest area. So that is giving information about the thermal patterns distribution around that area. That gives the interpretation what is the major causes giving this temperature deviation. Means loose connections may be taking place in that particular area, or overloaded. Due to this causes, we could able to find the highest temperature in that panel inspection, during the panel inspection. Likewise, transformer monitoring, and then circuit breaker switch gear, and then cable and bus bar inspection. See, bus bar inspection also is very important because it is collecting the power and distributing to the other circuits. So in that case, it should be analyzed, it should be monitored, it should be inspected through infrared camera. And then motor and generator monitoring. See, why we are taking this camera to taking the picture of motor means motor. See, in industrial purpose, the industrial motors will running for the higher temperature. So the manually we can't able to touch, and then we can't able to find out the defect fault without stopping any production. So without stopping any production, we have to find is there any fault, any defect, and then is there any maintenance need for the particular equipment. So through this camera we can able to analyze the temperature differences between the normal and then abnormal. And then the next one is power transmission distribution lines. Is there any leak or overloaded is there? We can able to find out. And then followed by substation inspection, and then battery system. We also monitoring the UPS battery. Is there any leakage is there, or any imbalance overheating cells is there? And then we can able to find out that. And then we also using in renewable energy system, and then predictive maintenance program, and then prevention. See, in electrical station, if it is overloading or is any loose connection, means electric leak will be there, and then it could lead to fire accident. So we can able to predict is there any leakage, and then we can avoid the fire accidents. And then during inspections, we have to see, this is the, we have to decide what is the priority we have to do. See, all manufacturing units, they have some standard operating procedures for their manufacturing product. So in that case, they have based on that, we have some suggestion for them. What is the temperature is, if it is below 100 Fahrenheit, means we have to give the advice to them when it is the corrective measurement. That means at this present there is no need to of doing maintenance, and then we have to advise them in what condition, in what when you have to do your maintenance, and then when you have to do your repairing process. And then so based on the priority is mainly based on temperature difference. The temperature difference will give the priority which is require more immediate requirements. And then based on that, we can able to tell these are all the examples behind the inspection. When we are going this, we can able to based on the priority temperature differences, we can able to see the priority of maintenance. And then this is your task See, here we have four different tasks. See, in normal images, we can't able to see the cable are perfectly connected with these panels and then everything. But through the through the camera, IR infrared camera, we can able to identify the highest temperature differences between the other cables with the leakage cables. So the next one also, the in this cable also, is there any leak is there or not? We invisible images we can't able to interpret, we can't able to come to conclusions. This is perfectly running conditions, so we should not able to tell like that. So when we are seeing through this thermal camera, we can able to identify where it is overloaded, is there any loose connection is there, or highly loaded, and then electric leak is there or not. So we can able to find out through this infrared cameras. So what is the advantage of using this infrared cameras? Means we are going to preventive uh, cost maintenance. So if you are running on unit manufacturing unit, if you are stopping the unit for 5 minutes or even 10 minutes also, you will get some losses in production and then whatever manufacturing. So this is going to be avoid those kind of those kind of cost of loss. So we are preferably using this thermal infrared camera. Within 5 minutes shutdown, we can able to rectify our problem, then the unit will restart. So when we if it is overloaded, is any electrical after fire accident, we can the whole unit will be in shutdown. So that will take to recovery for 8 to 10 hours. So it's going to be, obviously it is going to be affect your cost of manufacturing process. So this is the case study behind this electrical leakage. So using AI, that means in machine learning, we can able to identify the particular leakage. That means power substation. We can able to identify the monitoring the health of the insulator. This is the step-by-step process behind the this analysis. And then when we are coming into mechanical engineering, and then this is the predictive maintenance of machineries and motor and pump conditions monitoring, and bearing health observation and gearbox inspection, and friction and wire studies. And then followed welding joints. Is there any gap between the joining inspection? So we can do the inspection. And then manufacturing process monitoring. Lively, we can able to capturing the image, is there any manufacture process defect is there or not, we can able to and then failure analysis after you are fabricating or after you are fixing any unit. And then before start your unit or motor, you just take a one photo, that means take a image, capturing image, that will help you to identify is there any leak or is there any defect is inside this new unit. And then see, in this image tells us what is this, the purple. Obviously the purple color will gives coolest area. The three wheels you can able to see, because just we switch off the engine. So the engine part is giving more temperature, highest temperature, as well as that vehicle's tire also giving the highest temperature. And then in civil application, what is this main area? We are seeing the building inspection, diagnosis. So see, mainly we are focusing on the moisture content of the ceiling. And then when you have you builded a new residential building, so after that you just capture some few images, we can able to find out where it is there any air leak or missing insulation or insulation damage is there or not, and then moisture content we can able to tell through thermal infrared camera, as well as concrete and then pavement evaluation also we can able to analyze through this thermal camera. And then bridges, the health of the bridges infrastructure inspection, and followed by moisture and water detection in the building or top of the roof. And then next one is electrical and mechanical system in civil structures. So here you can able to see the escalator and then switch boxes. So when the switch is on, it will gives the highest temperature in that particular cable. And then this is the electrical and mechanical system in civil structures. And then fire and safety. And then this is the heritage. When we are architect persons, and or if you are going to inspect the ancient structure heritage building, you could able to identify these any crack or moisture content leak, everything we can identify. This is for your knowledge. Just have a look and then try to find or try to interpret this image. And then artwork, this is for your additional knowledge. I'm just giving some additional information. This is basically active thermography, but this is concrete sample. In that we can able to see when we are applying some light sources, we can able to identify the in-depth subsurface of the object. We can able to detect the defect. Okay. And then materials and manufacturing. Materials, when we are talking about material, so this is the oil stain on the desk surface. So the surface staining also we can able to identify. And then we paint coated paint coated one. After paint coated, we can't able to find out the knot and crack or decay one. So through this thermal images, we can find out the knots and then cracks in that particular wood material. And then here also the pine sample indicating the same. And then this is a retaining wall, the thermal images versus with visible images. And then environmental applications. What is that environmental application? Climate and atmospheric studies, and water resource and hydrology, and then coastal and marine environmental, air pollution and gas emission monitoring also. Recently we are focusing, the scientifics published a lot of research articles in agriculture and soil environment, and then forest and vegetation monitoring. And then this is going to be play a major role in waste management and landfill areas, and then wildlife and biodiversity studies. And then mainly focusing on this disaster management and environmental safety also we are using this camera. And then urban environmental monitoring. This is my own study. This is a novel technique which I applied for the for thermal discharges from power plant. So this is the study area. As this Kalpakkam, located in Kalpakkam, Madras Atomic Power Station, is the condenser effluent discharge into the sea directly. So using this camera, FLIR I-50 camera, I captured the digital images as well as thermal images for different seasons for different months. I fixed some locations, few locations. So these are the mixing point, and then southwest, and then after collecting those data, thermograms, I just applied this geographical information system. That means this software for making this distribution pattern, thermal temperature data around this coastal area near to the Madras Atomic Power Station. And then apart from that, as I told, we have to compare, we have to validate with our field data. That means the thermal images plus this institute data. For that purpose, I deployed uh, probes, thermal probes in different depth, and then I analyzed this vertically profile for temperature data in that particular area for different months, and then I compared with those data. And then we are entering into the science and healthcare. Pharma, sir, Dr. Lokesh sir is
Ma'am,
sir, is my time is over, or I have few?
you take your time, ma'am.
Okay, fine. Because I'm just entering into the science and healthcare. That's why.
Okay, ma'am.
Okay, sir.
Take your time, ma'am.
Thank you, sir. Thank you,
Thank
sir.
you, ma'am.
So previously we have seen this for engineering purpose. So first we have seen that we had seen electrical purpose, and then mechanical, and then is civil, and then environmental engineering. So these are the major applications of thermal imaging camera in particular discipline. And then next we are entering into the science and healthcare. See, science and healthcare, initially we start with the pharma industry and followed by biomedical applications. First, pharma industries. See, in pharma industries, the first major application is mainly playing a vital role in quality control, pharmaceutical quality controls. See here, what we are going to analyze, what we are going to say. See, in pharmacy manufacturing unit, they all are following the PAT tool. That means a PAT tool they are following. Based on that only, they are manufacturing their own products. So there is a sequence of steps behind this PAT tool. The first one is blending, granulation, milling, drying, and then tableting, coating. Finally, we will get our product. This is the PAT tool protocol. So followed by where we could able to apply our thermal camera to find out the quality control of the particular process. So in blending monitoring, we can able to apply this thermal camera. We can able to see the differences. That means heat blending is nothing but we are going to active ingredients will be there and the excipient will be there, so we are going to blending together. So during the blending activities, is there any uniformity in abnormality, or is there any poor mixing? So we could able to find the that means poor mixing, or is there it is a uniform blender one, or is there any particle is clumping somewhere? So we can able to find out the blending process. See, the right images showing the uniform temperature distribution while blending process. The left images you could able to see the hot spot, that is non-uniform temperature distribution. So the next one is granulation monitoring. See, when we are doing granulation monitoring, wet and dry process is taking places, and you are doing a granulation. So in that, camera mean uh, uniformity of the blender binder distributions. Is there any uniform distribution is there or not? Is there any cold spot is appears, means we could able to find moisture content is not dried properly. That means that ingredients is not dried properly. So the benefit of using this IR camera is early detection of the over wetting or under granulations. So this is the major one. The next one is drying monitoring. Or not even wet depth also, and then over drying or under drying, we can able to find out these parameters when we are doing the drying monitor. And then tablet compression monitoring. In that case, what we can able to see means, see the unit, manufacturing unit continuously running for day and night, so they are releasing batch by batch millions of tablets. So the continuously running, and alignment is there or not, there any lubrication failure or not, and then is there any overloaded in that particular machineries. So we can able to identify those defects, and then without stopping the manufacturing, we could able to advise, we able to give some suggestions what you have to do, what you should not do to that particular manufacturing persons. So in tablet compression also we can apply this one. And then coating monitoring process, we can able to see the tablet coating is properly coated with material, or that means not coated, uniform heat distribution is not is there or not. The early detection of coating defect we can able to identify through quality quality package, and then sealed vials, ampules. This is all medicines. Once it is the seal opened, it become contaminated, the patients, or we are not secure to use those kind of tablets, those kind of uh, tablets. Hello. And then manufacturing quality assurance, these are all the major defects behind in the quality assurance. And then this is the sealed box with container, the sealed container with tablets. So what is the difference between this sealed? We can able to identify the defects using this camera. And then freezing drying process monitoring also we can see. And then sterile room, that means when we are medical oriented, pharmaceutical means we are using the clean room area. So in that case we can able to, is there any air leakage is there, and then is there any electrical leak inside the clean room. So we can able to analyze, we can able to identify the those defects. And then predictive maintenance, as we told, as we discussed before, that means fire accident or before major interruption. So we can able to identify the defects, and then we advise them to rectify based on our requirements. So this is also applicable in the predictive maintenance. And then storage and transport validations. Say when you are transporting some drugs, vials, and then ampules, vaccines, one place to another place, means some drugs are very sensitive to temperatures. So those drugs we have to monitor through infrared camera. So we can able to find out, is there any temperature deviation, we can able to advise, we have to change this one. And then skin permeability, that means a drug, how it's playing a major role in that dermal drug delivery system. And then in animal research and preclinical test also, we are using this camera for identifying the pre and post recovery process, or a pre and post surgery. And then we are enter into the medical applications. These are all the different type of medical applications: dental, diabetes, breast cancer, personality testing, gynecologist, and then rheumatoid arthritis. There's a lot of medical applications. This is my own study, which is focusing on ocular studies. When I did my postdoc, I carried out this study. So this is instrumentation, say, experimental setup, and then this is the procedure what I carried out for taking the thermograms from different age peoples. And then this is the image analysis process. This is left eye, right eye, and then I'm just taking the cornea and then conjunctiva part, so collecting the thermal information, thermal surface distribution data. And then this is the normal SPS software using, and then we can get the line graph. And then using the MATLAB, I just focused on the cornea part. What is the temperature difference between the cornea alone? And then this is the outcome of the study. So surface ocular temperature, why I have to study this surface ocular temperature means this is going to be related with the glaucoma disease. Glaucoma disease is based on the temperature, pressure. So pressure, obviously, if it is pressure get increase or decrease, means the temperature variation will be there. Based on that, we can able to tell the ocular surface temperature. So the patient should have, so the maybe might have be glaucoma disease, so we have to treat accordingly the detection. And then the finally we end up with the objectives. How we have to prepare the reports. You have to take a few numbers of images of particular without checking your position, angle, everything. And then you have to collect in-situ data also for your validation. After that, this is the step by step report. First you have to describe the objectives. First information, you have to give the basic information: title of the project, application area where you are going to apply, civil or mechanical, electrical or material, whatever. And then location, inspection date, prepared by. This is the basic information, followed by objectives, and then principle of infrared thermography. Equipment detail is very important. And then next one is inspection methodology. You have to describe in what methodology you just carried out for this taking the thermograms. And then thermal images, and then interpretation, finally limitation. You have to do safety, conclusion, and recommendation is very important. You are going to give a quality assurance report, so you have to recommend, you have to give your suggestions to maintain the proper. So here is the digital images and then thermal images. See, without a naked eye, we can able to visible images. The AC is there and two electric point. That means a lamp is there. So we can't able to see this false ceilings moisture content. In this thermal camera, we can able to see the moisture content. That means water leakage in the false ceilings. So like this, you have to prepare your thermal imaging report. And I'm going to end up with this session. I hope you gain some knowledge, because this is a big vast area. So I just want to give some ideas, because this is a faculty development program. So I just giving some idea where you can apply, and then what you will get, and then how we can interpret, and then what is going to be quality assurance. So in that way, I just covered all the areas, the engineering, science, and then healthcare field. So based on that, you can develop own projects, or you own your research one, and then students research also. So it could be helpful for your future research. And this is more that means this is quality inspection tool. So I prefer to choose this camera for inspecting the based on your requirements. You can able to apply this camera. In addition to that, you have to validate. That is the one thing. Anyway, see, wherever you are going to deploy some equipments or whatever, we have to do validation and calibration. For this also same. So I hope this session is going to will be given more information about infrared thermal camera. So this is my communication address. If you are willing to any collaborative projects, or if you are interested in this in thermography, you can contact me through this contact number, and then this is my email ID. And then thank you for all of you for presenting this session. And then I presented this session for your presence is very valuable to me to develop in my future also. So thank you once again. And then I would like to thank to Department of Civil Engineering, Dr. Seduraman sir, for giving this opportunity, sharing my knowledge and experience with young researchers, or young um, what to say, that means young professors. So I hope it's going to be helpful for your future careers. Thank you all of you.
Thank you, ma'am. Any questions from participant? Any questions from participant? You can post your queries in chat box, or you unmute yourself and speak.
Link.
They are asking about the feedback link.
Oh,
Nat query, ma'am.
okay.
Oh, okay, ma'am. Based on your thought, yeah, we can be able to understand everything, ma'am.
Okay.
Thank you for your valuable time to spend with us, ma'am.
Yeah. Thank you for this opportunity.
Okay, ma'am.
Thank you all. Have a nice night day.
Okay, ma'am. Thank you, ma'am.
Thank you.
Thank
Can I
you.
leave, sir?
Yeah, ma'am. Sure, ma'am. You can do, ma'am.
Yeah, thank you. Bye, sir.
Thank you.
Right.
Bye, ma'am. Participant, we post the feedback form in chat box. You can fill the feedback form and you can leave from the chat.